My name is Nicolas, and I've been doing Scala for quite a while now. And I've been invited to this conversation to share my expertise on stuff that I don't know much about, and I'm going to improvise the whole thing. I'm going to start the conversation off property-based testing, which most people hate. So I hope I'm not losing you too many viewers right now. What I've been working on in the past 6 months, 1 year or so, Scala has these features that it's not new, it's in development. It's not exactly new because it doesn't really exist yet, but it's called capabilities, which, the promise of capabilities is we are going to be able to encode effects in the type system without having to use monads. And that tend to wind up so much of the Scala community. They absolutely hate the notion of not using monads. And so I thought, well, that looks interesting. That looks entertaining. I want to learn how that works because there's good entertainment value to be had there. So I have been studying that. And then as a result, that's brought me to algebraic effect and effect handlers, which Fabio has been educating me on. It's been a rough ride because he's a stern teacher, but it's quite cool. And then, of course, now that I understand these things a bit better, I wanted to put them into practice using my other love, which is property-based testing. And so I have written a property-based testing. I think it's my 12th property-based testing library. The first 11s were absolute rubbish, entirely unusable except by me. This one might be usable by a few more people, but not that much. But I decided to write it entirely using capabilities. And while doing that, I discovered there's quite a bit of friction between the way I'm used to doing things and the way capabilities want me to do things. And in order to solve these frictions and to work around them or to work with them, that's brought me to a design which is not at all what I intended to do in the first place, but I'm quite happy with. And I don't know if it's useful, but I think it's really fun. So I wanted to share that.
More useful to more people than before because of capabilities?
I think the constraints that I was working on because of capabilities prevented me from doing the stuff I was used to doing. And so I had to come up with novel solutions. I even had to reinvent. There's one bit where at some point we might talk about test case reduction. And I thought so long and so hard about that, thinking, okay, I can't do it the way I'm used to doing it. How could I possibly do that? And then I came up with a brilliant solution. I was very happy with myself. I think I jumped up from the couch and scared the entire family by screaming, I am so incredibly smart. And I was very proud of myself until 10 minutes later, that's exactly the solution that David McIver came up with. And I already knew about that. So I've come up with having to fight against this friction has caused me to write stuff in a way that is a bit weird to me. And that has created lots of possibilities that traditional PBT libraries in functional programming language don't really have. We just don't think that way because there's a lot of mutability involved and stuff like that. So I think it's nicer to use than traditional PBT frameworks, at least for casual user. I think it could be a gateway drug into property-based testing, really. Also, I have to say, in development, there are going to be bugs when I demonstrate it, obviously, and I haven't released it. It's on Codeberg, so you can have access to the code, of course, but you can't really use it. It's not on Maven Central yet, but if enough people say, actually, that looks interesting, I could see about releasing it.
You said that people hate property-based testing. That's news to me. I thought everybody loves it. They just struggle to find kind of use cases for it, but whenever you do find one, then you're really proud of yourself and you go around.
So you're one of the good people, but people love the concept of property-based testing. But when you actually have to do it, it is dreadful. I mean, it really is. So are we assuming that everybody who's listening to this knows what property-based testing is? Or do you want me to quickly explain?
Doesn't hurt to explain a bit, I guess. Yeah.
So property-based testing is traditionally opposed to example-based testing, which is a very pretentious way of saying the kind of test you used to write. You have your system under test, it's a function you might want to test, for example, and you say, well, given this input, I run it in the system, observe the output, and if it matches my expectation, the test passes. And property-based testing says, well, you have tested one possible input, and there's an infinite amount of possible inputs. This gives me very little confidence that your system is actually working as expected. So solutions here, you could prove it correct with RockCock, for example. That's a lot of work, very specialized knowledge. You could use TLA Plus, for example, to prove your algorithm correct and then re-implement it. That's also a lot of work. It's fun, but a lot of work. Or you could test on more test cases. And property-based testing or really generative testing tells you, what if we generated random inputs And then we figure out whether the test still passes. And the most popular version of generative testing. So generative testing means generate random test. And property-based testing asks you to come up with universal properties. So you say for any x, P of x holds, where P is a property. So it's universally quantified. It's a property that has to hold for all inputs. And it's really very hard to find such properties. When people tell you, oh, property-based testing are great, here's a property. When I sort a list, its length must not change. And everybody goes, yeah, but I'm not going to implement a sorting algorithm. Give me a test that I'll write. And that gets a lot more complicated because it's very hard to find properties of systems. There's the obvious properties that everybody loves. It's great. It is when you do encoders and decoders, right? So you have the round trip property. If you encode and decode, then you must get what you started with, modular errors. That's great. That's amazing. It works all the time. It finds very little errors usually because most of the time our encoders and decoders are automatically derived. So if that works, you're really testing again what somebody else did and already tested. So it's not actually that useful in practice. And other than that, the way people write properties tends to be, well, I have a system under test. I'm going to rewrite it for my test. And I'm going to make sure that when I run both, they give me the same result. That's a lot of work. And usually the same person implements the original version and a test version. So really, you're just testing that you have managed to write the same algorithm twice the same way, which is not a useful property to test. It's not interesting, right? So in general, properties are very hard to get right. And by the time you write them, you realize, not that useful. So much work, so little benefit, I'm not going to do it. People do love the concept though, the idea of, oh, I get my test cases for free and then I get the smallest possible test case that fails my test. And then, oh, it's amazing, but I just don't want to do it. I'm going to talk about it at conferences because everybody loves a good talk on conferences, but a lot of people don't actually use it because it is so much work and it feels like such a slog.
Or sometimes you do it and then you have to refactor stuff, or people just remove your stuff and then the property-based test doesn't work anymore and you have to remove it. Have any good examples or anything positive to say about property-based testing?
I think they're amazing once you take the time to learn how to write good properties. I haven't run that experiment yet, but I really want to at some point. So a specific kind of property-based testing of a property is a metamorphic property. But really what it says is, given some input, I'm going to run it in the system. And then given the same input, I'm going to transform it in a way that I control, and then run for the system, and then I should be able to match expectations. So a good example of that is something that we used to do. Our previous work, we used to try and spot faces in images, right? And so a metamorphic test for that could be, well, if I run an image and it spots a face, and then I take the same image, I rotate it 180 degrees, and then I flip it, and then I do a bunch of transformation that I all control and know, then the output should be the same as that one with the same transformations, right? So if you apply the transformation, so you get, and if it's an image, so it's not going to be exactly the same, so you have to build in some resiliency, of course, but if it's roughly the same, then you know it works. What's really cool about that, you can run it in production because you have the input. So instead of having random tests, what you do is you have actual test cases in production. You have actual stuff that you know people see. So this is not something, property-based testing very often find edge cases. That's an interesting edge case, but that's never going to happen in production. So if you hook that in production, then you see, well, that actually happened in production. By definition, this is how we got the test case. And then you can run metamorphic testing on the side without, so it doesn't impact your platform. Then you find lots of small test like faces where, oh, when I do the rotation, suddenly it spots a dog and not the face I was looking at. So it's really cool to be able to run this kind of test in production. So there's property-based testing. Once you have learned the skill of writing properties, is fun, is interesting. There's so many ways of writing good properties. I actually have a talk on the subject. I think the title of the talk is better than the talk itself. The title of the talk was Much Ado About Testing, which I thought was really fun, in which I explained different strategies to come up with it. I explained what decision tables are, because that's another thing. Decision tables are really great to write specifications, and you can automate the transformation from a decision table to a set of property-based tests. So there's very many ways of writing property-based tests, but the truth of the matter is people do not like writing tests. And even if property-based tests make writing tests easier once you have acquired the skill. People don't want to say, I'm going to spend a month learning how to write proper tests. People go, no, I'm just going to do example-based testing, right? Because I know how to do that, and most of my programs don't have bugs that kill people. So, that's fine. And so it's not that people hate property-based testing, it's that people don't want to spend the effort to learn them. And I completely understand. I'm not criticizing people here. Property-based testing, especially property-based testing libraries, as we use them in Scala or in Haskell or in other languages, tend to be very hard to understand and to work with. There's a very high bar. Like, you have to understand what a property is, and it's usually not that easy because you have to combine them in weird ways, and then you have to learn the concepts of generators and shrinkers, and they make it very hostile. So there's been some effort there, but on the whole, there's a barrier to entry that is too high for most people because most people don't want to spend so much time on tests. So after this preamble, the library I'm writing, completely by accident, almost by mistake, solved that problem in a way that I absolutely love. Because, well, I have a way in which I like to write a test, which I'm going to demonstrate. An example from one of my previous jobs. It's going to sound like a silly example, but it's also something that actually happened. So it's a proper problem that I had solved through property-based testing. So in that job, we were doing web services, because what else are you going to work on these days anyway? Well, web services had users, and you had to create users. And we had, one of the rules that we had was, you can't create a user who's not an adult. And so we wrote a user data type that had an age and a predicate that is an adult. And somehow we had a bug in there. I think it was because the age of adulthood was different from one country to the other, and we had a bug in the logic there. And so what happened was that if you were 25, you were never considered to be an adult. And we wrote an example-based test, and that didn't work out so much. And then we improved on it. So let me do that quickly. A user, let's say, has a name and an age, right? So there's nothing too complicated there. And then in a companion object, we created a predicate is adult. Actually, let's make it a method. That's probably more reasonable. And I would go the obvious, so age greater or smaller than 18, and the bug. Now the bug is quite obvious. In our code, it was not that obvious, right? It was obfuscated through layer and layer of Java beans and stuff. But really, we thought we had written that, but we had written that. And so we wrote a test for it, which we'd call is adult behaves as expected, say. And a test, well, we wrote it, your typical example-based test. So the input is a user whose name is, say, Jay, and whose age was. We enjoy testing edge cases, right? We know that's usually where the bugs are. So the only edge case I can think of here is 18, because that's one of the boundaries. So it's a good value to test. And we do then assert input dot is adult. Actually, probably don't need to make that apparent. Anyway, something like that, right? And then we'd run the test, which we're going to do here. And that passed. Is adult behaves as expected. And we tried it just once because there's only one input, and that worked fine. Obviously, there was a bug and we didn't see it. And that's the point of property-based test, right? That if I just write the case I can think of, then I'm not going to test all of the cases I haven't thought of where the bugs lay. And so people are going to say, well, write a property. So I prefer for these kind of problems to do not property-based tests, but the more general generative test, where I make my input random and see what breaks. The way you do that is by saying, well, the first step is identify the bits of your test case that shouldn't matter to the test. So here, the name doesn't really matter. I should be able to make it completely random, right? And so I'll do that. In order to create a completely random name, I'm going to create random name. I'm going to explain the using bit later. It's not important for the moment. And that returns a string, right? Random name returns a string. And to keep things simple, I'm going to say that the first letter of a name must be an uppercase letter, and then the rest is all lowercase letter, and this is what I return. So first is going to be rand.alpha uppercase. And then rest is going to be rand.lowercase. list of rand.alpha lowercase. And then I can just const2 and make it into a string, and that bit generates a random username. I'd create a random username and say, well, the input now takes that name.
I think it was char instead of case.
Did I say case?
I wasn't sure before, but now with the compiler.
Okay, so now it compiles, it runs. We see that we haven't run one test, but 100. That's a massive improvement in user experience. Instead of saying, hang on a minute, this is no longer a test, it's a property-based driven test. And so I have to do a for all name, which is a string, then I create a property, etc. No, I just said, okay, the name is random now. And I didn't have to change anything. It's just, I just have to say it's random and the library is picking up on it. And now it's running hundreds of tests just to make sure that it explores the test space in a way that's interesting. Of course, I didn't find any bug because we don't have a bug in the name, we have a bug in the age. So let's create a random age. For the purpose of this test, let's say it's going to be between 18 and 99. Something for any users that I expect to be an adult, then it must be an adult. And adult behaves as expected, failed after 18 attempts with a completely useless error message. This is nice, but I have no idea what went wrong. So we could improve on that because you have the ability to log the inputs that you think matter. So I could say, log this as a name, log that as age, and run the test again. And now this is telling us a lot of things.
I like the name.
It's the smallest name it could generate because this has been shrunk. So we can talk about shrinking a little later. But this was not the original failing test case, which probably had a name like Flumurgik. But this is a shrunk name. It's not great because I haven't put so much effort into it yet. But it found exactly the problem, and it had made all the other moving bits as small as it could be. That's how you get it. And you also have this interesting thing which allows you to replay a test case if you want it. So you have a bunch of things here which allow you to play with the data. And I think this lowers the barrier to entry to property-based testing because really, I didn't have to do anything complicated. I didn't have to rewrite my system under test. I didn't have to figure out a property. I just took an existing test case and made the bits random. And then I changed nothing else, and it turned into property-based tests with shrinking, with all that. And so that's probably a bit of a letdown in that from a user perspective, that's all there is to it. But I think it's great that this is all there is to it. Now the implementation is a lot more exciting. But from a user perspective, I write a test, I make it random, and everything works out, and I have nothing to do. So there, and of course, we could do a nicer error message here, obviously. It's not that interesting, but inputs.name was not an adult. And then if we rerun it, let's see, we have a different name now, slightly smaller, completely unrelated, but yeah. So that's basically the experience as a user, which...
So if I'm a just regular test writer person, I've never done property-based testing, I could say, oh, but I have random in my language. I can always just do random dot, or I can have like a fuzzy library and fuzzy thing. The cool thing here is, if it wasn't clear, the test reduction, right? And then the shrinking. Like you're not gonna get it from a random string or a random library. If you use naive random string, it's just gonna give you giant random UTF things and then random characters, symbols, right? It's just gonna be so wild. And here you get everything kind of way nicer for you, right?
So absolutely correct. And also, I didn't have to write anything for the shrinking. I don't know if you've used Scala check or quick check or thing like that. Shrinking is a problem. And here, everything is done for you. So you don't have to pay the price of having to implement all these things. You get a reasonably good version out of the box. One of the reasons why shrinking is a problem, in Scala check, for example, it's type class driven. So you have one type class called arbitrary that allows you to generate random values for a type. And you have another type class called shrink that allows you to shrink values of a type. But these are both different type classes very often you'll find yourself in scenarios where the generator and the shrinker don't match. So for example, you say, I only want to generate numbers that are over 18, but the shrinker, since you haven't written one, is going to pick the default shrinker for ints, which shrinks to 0. And so your library is going to tell you, I have found a case that doesn't work. If the user is 0 years old, he's not an adult. And you as a user think, well, that's a bug in the library because clearly I didn't write that test. And PBT users are going to tell you, it's a bug in your test. You should know about shrinking. I argue it's a bug in the design of the library because you shouldn't have to think about these things. And Hedgehog, which is another approach to that, fixes it in a different way. What they do is that they have integrated generation and shrinking in the same type. Well, it's not even a type class, in the same type. And so whenever you combine two generators together, when you flat map them and everything, then that at the same time that the shrinker under the hood, so that your generator can also shrink things in a way that should match exactly what you have generated. Now, these two strategies are typically what you'll find in the functional programming languages, and they're called external reduction, as in you get the test case and some external tool goes through the test case and shrinks it. Now, there's another approach which should be more popular than it is, but it's a little crazy, and I'm always very surprised when it works. It's called internal reduction. And that is what Dr. McIver came up with in his library hypothesis for Python. It's completely weird. His idea, the mental model he has for that, I don't know if it's that useful, but some people like it, is a random generator is a parser for a list of integers, where the integers that you generate the list of integers are the numbers that you're going to pull those are the random numbers that you're going to pull. And a random generator is just a parser for this list of integers. So you go through the list of integers, and for each integer, you do something with it. And so if you rerun the same parser, the same generator, on the same list of input, then you should get the same result. What if, instead of shrinking the result, I shrunk the input? I shrunk the list of generated numbers.
Mm-hmm.
That is really weird, isn't it?
I get how that works, but
This is how you get that. This is how you get here. It's just completely weird.
no, maybe I do. But how do you shrink it in such a way that you get meaningful stuff out?
It's a parser that can't fail, really, because let's look at random number generation. So
can I try like simple, stupid example? Like, for example, if you have 0 for false and 1 for true or something like this, and then you fall back to false being 0, or it's way too...
For example, but let's say that you have 1, 0, 2. Generate a list of integers, and the first number I pull is the length of the list. So it's going to consume the 1 here, and that's going to create a list of size 1. Mm-hmm. I'm going to generate a random number. I'm going to stick it in there. So the next number is 0. So I'm going to put 0 here, and there you go. It's going to ignore the 2, and it's got a list of size 1, which contains 0 as an element from this list of random numbers, of semi-random numbers, because they're not random, they're here, but yeah. So the way it works is, I'm very sorry about the Scala. This is Scala. I know you don't like it, Mark, but I think it's readable. And honestly, if it doesn't make sense, feel absolutely free to interrupt me and ask for clarification. I know that Scala syntax can be off-putting. So the notion here is I've created a rand capability, and we can get into capabilities a bit later. It's only got just one operation, generating a number between 0 and max. And it's a trait, which means it's an interface, really. It's a pure abstract class. And then based on that method, I can write a whole bunch of stuff. Alpha upper car, where was it? Okay, something that's easy to show. Frequency is quite hard. 1/2 is quite hard.
What was the base method again? Did it have did it get a seed as input or something?
No, nothing.
Just
it's an effectful operation.
Okay.
So if you have the capability to produce random numbers, you can call nextInt. And that somehow is going to generate a number. That's your capability. Some people will call that your effect or your effectful operation. NextInt is, and then you provide a handler. And all of a sudden we are firmly into the vocabulary of algebraic effect and effect handlers.
Okay, so it's like an interface, right? So I could provide my own completely random one or my pseudo random one, whatever.
Okay, let's do that.
No,
absolutely.
Sorry.
You're absolutely right. This one is semi-random because it's backed by the standard random in Scala standard library, which is, I think, based on the system clock. And so that, and the implementation, this is one possible implementation, but the way you do it is not exactly by providing rands, is by writing this kind of method, which I absolutely hate it, but Martin Odersky has decided that's called a prompt.
Good luck getting that to be Googleable.
Yeah, exactly.
Oh, but nobody Googles anymore anyways, right?
And so here, for example, this is telling me, here's the seed that I want to use. And if you give me a computation that depends on the effect rand, on the capability rand, and returns an A, then I'm going to run it to completion and return an A. Right? And so later you would call it by saying, for example, with seed 12, and then I can do rand.choose 0, 100 here, because I'm being executed within the scope of with feed, which provides me with a rand capability. And the rand capability is exactly what you said. You can write your own handler. So we have a bunch. We have this one, which is based on the standard library. We have this one in which you have said, I don't want to ever generate a number higher than this value. And of course, that depends on another random generator, right? So you take a random number generator, you call it, and then you cap it. And the important one, the one that was complicated, the one that took me a while to figure out, that I could do it, that I was allowed to do it, is record. So this one, it looks a lot like the one I showed you before. It takes a computation from rand to some A, and an existing handler, and it's going to return something that's a recorded. Recorded is the product of the random value that has been generated and all the states that have been generated. So state is a list of int, right? So all the numbers that have been pulled. So now, in my test, I can say, the user wants a random number generator. I'm going to provide one to him. And while they run it, I'm going to record every single number that's been pulled. And so I have this list of int, and I can replay it if I want. This is how replay works. So here, for example, instead of rerunning it every single time and getting different failures, I could take this token, which is just an encoding of a list of integer. And no, it's exactly the same one as before, right? It's played exactly the same test case, because I have saved the random number generator sequence, the random number sequence, and replayed it.
So that's a cool thing, right? You just have the one thing, right? Which is just give me some ints, and then you can just based on that write all the like choose and like all the magic stuff, right?
And that choose is basically the same thing as next int, for which I've provided a useful helper. Instead of saying 0 to max, it's min to max, right? So I get a random number from, let's say, -100 to 100 if you want. But you could also do that for characters, because characters can easily be transformed into integers and then back to characters. So I can do choose of AZ here, for example, and that's going to return a random letter between A and Z. Same for shorts. Booleans are, I'm going to generate a random number between 1 and 2, and right?
I was just curious because I think I saw in your implementation you have this thing where you say it should be between 0 and an upper bound, and then you use the random thing, and if it's kind of outside of that, you map to 0.
No, that was specifically
It's the one that we don't use.
Bound one. That's in that one, right?
Yeah, I was just kind of in general worried if you did that, whether you'd get way too many zeros, or like how in general, kind of when you cap it, how you make sure that that doesn't happen. Do you have to do like mod or something?
Is this the one that you talk about?
Yes, I think that's the one where I was like, what does that mean for like, I don't know, your distribution of your randomness?
Max here is what the user requested, right? So if the user says, I want a number between 0 and -10, then I'm going to return 0. So it's because it's giving me a wrong input.
I'm not sure if it answers the question I had, but maybe I should rephrase the question.
No, I understand that you mean that if I'm skewing everything towards 0, then, but I'm not skewing anything towards 0. I'm only handling the incorrect inputs. Right?
Oh, okay. So it's just like because you don't have like unsigned int or whatever as a
Exactly.
type, you're like, okay, I see. Yeah, then
It-
I misread that. But that still maybe is a thing, like just naively, something I think I've struggled with when I was trying to do generators is like these kinds of things, right? Like maybe I don't have choose.
I haven't looked into it too much because Scala has a native implementation that does it for me.
So
Because
you just get, okay, nice.
I'm just using it as a standard library once. I haven't yet because that was not the point of my experiment. But for the moment, the main generator is just a proxy for the default one in the Scala library, which is known to work.
But because I think, I mean, you probably might run it like when you get more precise with your own types, you know, I don't know, you might want to generate some special strings, right? Like maybe you want real names, right? And then you want stuff to be maybe Unicode, but maybe not emoji, right? But only like Chinese characters, these kinds of things.
Okay, so that would be choose. So let's say, for example, that I want to return something that is in the, well, I can choose a range and turn it into a character, but let's show one with unions. Right, okay, here. I'm saying, well, an alphanumerical character is one of these, and just pick one at random.
Okay.
Now, your point might be, there's more characters here than here, so I'm unfairly representing alpha lower car over num car, or num car.
My brain didn't get there, but yeah, I'm curious.
Well, if you want to go that deep, you have frequency, which is a common combinator, where you do something like that. So for Booleans, for example, I might want to say 9 times out of 10 true, and the remaining time false.
I mean, the thing is, I'd be worried when I write my own tests, whether I've written something that, again, gives me kind of false security, right? Like saying, okay, I've only created one example or two, and that seems to work, right? So I'd be worried that maybe in some cases I just do it wrong.
So
interesting
this is a very interesting question, and there's a bunch of research on the topic, which I haven't at all integrated yet. But John Hughes, who is famously the inventor of property-based testing, and who wrote QuickCheck for Haskell, solves the problem by allowing you to track statistics on the value you generate. And so you can create classes of tests. So for example, I would say empty string, I flag that as the group empty, and non-empty string, the group non-empty, and max out string, the maximum length max string. And then when you run the test, it tells you, and you have generated 99% empty strings. And so, you know, oh, my generator is not good. It is giving me false confidence that things are working because 99% of the time I'm actually generating the empty string. So the problem you're describing absolutely exists. It has a solution. I haven't implemented it yet. It's not the hardest thing in the world, but it's not there yet.
I mean, that's fair enough, right? Like you've probably implemented it 11 times already before, or maybe once or twice at least in the 11 versions before this. But I think it's also just because, like, yeah, the general thing, right? Like you're saying at the beginning that you want to write the properties, but you also kind of want to increase your confidence and not decrease it. And that seems like a cool thing, actually. It's a great idea because I also feel like, you know, you can often in many test frameworks, you can generate lots of reports in like 400 different formats and this HTML and that.
Yeah.
And it's usually just, you know, always the same green stuff, right? But something like this, I would think, yeah, that's actually pretty interesting, right? And you can, at this point in time, that's when you might want to check it, just like see some kind of distribution thing. I'm not saying you should implement it or whatever. I'm just kind of curious about the whole thing. Flip this in the sense that, like, why do you have frequency? Isn't that already too advanced then? For the
like frequency is a primitive already, because like a lot of libraries do for options, right? Like you don't want to generate none once, and then you want to iterate over the stuff inside the sum or actual values inside. Or if you implement your own enums or your own EDTs, it's just quick to say this value is not interesting. All the other ones are more interesting.
Exactly.
So what does the 1 and the 9 mean? Is it like out of
this? You sum these two, and this is telling you out of 10 pools, I'm going to pull none once and sum of 8 9 times.
Okay, so it's really just like 1 out of 10 and 9 out of 10. Okay.
So it describes the distribution, and then you pull a random number between 1 and 10, and if it's 1, then you go for none, and if it's 9, then if it's any other one, you go for the rest. The implementation is a little bit thorny, and I think I'm going to shock no one by saying I got that from Scala check, ripped it out, and adapted it to my framework. But basically, the algorithm is not mine, it's Scala check's. Because Scala check, I don't like the way they do shrinking. but it's other than that, it's quite a good library. So there's a lot of inspiration from that. I mean, if you look at all the name of my combinators, intentionally, they're exactly the same name as the one from Scala check because people are used to it.
What's up with capture check in there? What is it? What?
Do you want to talk about capture checking?
Maybe for a second, why doesn't it like it there? I don't get the awkward part.
I have to explain what capture checking is if I want to explain that. So capture checking, Ma, are you at all familiar with it or not? All right. So capture checking is used to solve one very specific problem, which you must have encountered. Well, for example, you're working with Go. So sometimes you open resources, like to a file that you want to write, right? And well, I don't actually remember how it goes in Go, but in Java, for example, it's a lot of faffing because you have to open the stream, and then if you fail to open it if you fail while you open it, then you have to throw an exception. Otherwise, you have to work with it. But if there's an error here, you want to catch error and make sure you close the stream before you forward it. And there's a lot of pain in there. So
is it like bracket? That's how I would think about it.
It's exactly resource management. That's exactly what I'm talking about. So typically in Scala, you would write it something like with file, for example, and you take the name of the file and then a function which, given an input stream on the file, returns an A, and I'm going to return A here, right? And the way you do it, I'm going to say out is going to be new file output stream name and f that result equal f of A. Then I'm going to do resource cleanup and then return the results, right? This is obviously not great. And so that's, now that I've shown you that, you don't have ever to deal with opening the stream. You just call with file, and then you pass a combinator that takes the input stream and do whatever you want with it. That's reasonable, right? That sounds fine. And Java has that. It's called the with resource pattern. And it's present in a lot of languages. I think bracket is another name for it, as you said. What do you think happens if I do this? Logs.txt, and what I do is, this is going to be a stream, and what I do is I return a function that captures a stream. I don't know whether my parents are balanced. Let's pretend that they're not. Now they are. So if I do that, out is now a function that takes no parameter. Well, actually, to make it easier, let's do it that way. Right? A function that, given an int, writes it to the stream. But what do you think happens when I do out of 1?
So the problem is that the file is going to be closed already by the time I want to run it.
Exactly. So that's a problem that capture checking wants to solve. Capture checking tells you, right, I want to annotate input stream in such a way that it's not allowed to escape the scope of this method. So if you do this, which adds some further funny syntax to Scala, the compiler is going to reject that call because the input stream is escaping the scope of with file. And you have told the compiler, you can't do that. Input stream cannot escape. So capture checking is some type level shenanigans that allow the compiler to make sure that the values you don't want escaping the scope, that you don't want to be captured and then escape the scope, are not captured. Hence capture checking. It's very much a borrowed checker.
So which one does it disallow? The lower one, right? 352 you cannot do anymore because you can only do stuff inside
Exactly.
of 346.
I could absolutely do stream.write 20. No problem here, right? Because I'm not capturing the stream, but if I capture it and return it, then it escapes the scope of with file, and then the compiler complains. And so this is actually the hard part about capabilities, is capture checking is weird.
Just a step back, is it, so capabilities are not part of Scala 3 yet, so you said it's still in process, kind of experimental feature, and similar capture checking, are they both experimental in some version? So how are you using it, and how is it coming together?
That's actually a more complex question than you think. Capabilities is fully in the language. You can use them now. Capabilities are just context function. A context function is that, where the arrow you use is the slightly confused fat arrow, right? That means this is implicit, and it just describes whatever's on the left as implicit. And this is everything you need for capabilities, unless you want to avoid your capabilities, you want to prevent your capabilities from escaping the scope.
Uh-huh.
Capture checking comes in. Capture checking is experimental. So you can absolutely use capabilities today if you want, except you will have the problem if your capability, for example, has mutable state. Then it might escape its intended scope and you might have bugs at runtime that you don't want to have. Capture checking solves that problem. And then this is where there's a long discussion to be had, something where Martin and I disagree. Now, I'm not going to pretend that I have any input on the way Scala is designed. A couple of years ago, a while ago, I was in Krakow for a conference, and the local Scala user group got in touch and told me, right, you're in town, why don't we have a meetup and you can improvise a talk? Which, I didn't really like the idea because I don't do so good at improvisation. But I thought, well, I could talk about capture checking. I've been studying that, and that's a nice topic to talk about. I could live code it, and I don't know if you've ever seen me live code. I am dreadful.
We just witnessed it for an hour, but yeah.
Well,
improvisation and live coding has been doing good.
Well, that's mostly showing code that already exists more than coming up with new code. And they told me, right, why don't you live code something on capture checking? That sounds great. And anyway, it's all going to be a few people. It's just going to be friends. I've never been to a meetup that packed. I think there were more people than the room could contain. And there was another person that they didn't come to see me. No, they came to see Martin, who was also invited. So I was going to go on stage in front of Martin, criticizing and explaining what he's inventing, working on at the moment. And that's a dreadful thing to do to anyone, because you know it's not going to end well, don't you? So I already had some unfortunate experiences with Martin. And my first ever talk at a conference, it was a talk about the what's in the Scala language. All the things that had been improperly designed and how to work around them. Walk in the room. First conference talk of my entire life. I think there must have been 12 people in the room, but I counted 700, obviously. And go on stage, look to the right. Martin is sitting here. So me, absolute utter nobody, explaining to Martin Odersky why his language sucks. So that didn't exactly fill me with confidence. But I thought, well, Martin doesn't speak French. Funny thing about Martin, he speaks French. I should have known that. He works in Switzerland, right? He works in Lausanne, and in Lausanne you have to speak French. So I should have known that. I didn't know that. And so I was very surprised when 5 minutes into the talk, very politely raises his hand and said, right, young man, what you just explained, I think you understood it. I think you understand. I think you nailed it, but you explained it very poorly. Can you try again, please? And the talk that was supposed to last half an hour lasted, I think, an hour. And he ended up being a lot of back and forth with Martin and I. It was absolutely dreadful. Everybody had a grand time. I hated it because it was so stressful. And so I knew that Martin could be quite nasty, but so in that Krakow talk, we're back to the Krakow talk. I have layers in my segs.
Yeah, and you should keep always the limited continuations of the talks.
In that talk, Martin, he saw that I wasn't comfortable about giving that live coding in front of him. So he said, let's do it together. Let's go on stage together. You write the code, and I'm going to criticize it, make fun of you, and explain why you're wrong. And that sounded brilliant, right? Suddenly I had to do two things I hate. I had to live code in front of people, and I had to share the stage with somebody better than me. So we gave this entire talk. We learned a lot about capture checking because it was still in its infancy. And I showed a lot of things to Martin. This could work better if we did that. This could work better if it worked that way. And he said, you don't understand capture checking. Because, and this is where I disagree with him, Martin, and I completely understand that. Martin wrote capture checking, designed capture checking. The EPFL team invented capture checking in order to prevent capabilities from escaping the scope. But I see capture checking as a more generic problem, as solving a more generic problem, not capabilities escaping the scope, but values of any type escaping the scope. And so I see capture checking and capabilities as two disjoint features that work well together. But the EPFL team sees them as the same feature. So as far as I'm concerned, you can use capabilities right now. And if you want, you can enable capture checking and play with that, although good luck, because it's in development. It has rough edges. But Martin and his team see them as the same feature. And so capabilities are not really usable yet because capture checking is not finished.
Okay.
So there's a disagreement there.
If they were the same, then why can you even release capabilities before you have capture checking? If it doesn't work on any value, it should only compile on capabilities. So is that what it actually is?
So it works for most values except some, and the some values are not very well documented. So for example, adding capture checking, if I have this type, this means it's tracked. So I don't want my A to escape. But it doesn't work for any A. So if I do it for string, the compiler is going to ignore the annotation because string is known to be an immutable type, and it doesn't have, since it's immutable, it doesn't need to be checked. And I thought, well, I disagree with that notion. I would love to be able to track string. Imagine, for example, that you're working on a library that does secret swapping. So for example, I could do with secret, very similar to what I did before, where you take a function that takes a string, returns some A, and the string is the secret. And so with that, I would really love to be able to say, well, I want to flag this as something that's tracked. So that I know for a fact that nobody's ever going to be able to extract the secret that I give you outside of the scope of with secret. And so that way I can use it maybe to initiate a handshake with a remote service, and then I get the proper secret, and then I use that. But Martin and his team said, no, string cannot be checked. Exceptions cannot be checked, cannot be tracked. I don't know why. There was a reason. It was explained to me, and when it was explained to me, I understood it. But I forgot, and I can't give it to you.
The answer is capabilities, right? Like you shouldn't be using string, you should be using some capability here or something like this, and save for exceptions and something like that.
This is where the disagreement comes in, right? This is what you said is what the PFL team thinks. But I think I should be able to track string if I want to. I don't know why I'm not allowed to.
But so just again, for me, I'm not sure I completely understood the capture checking thing. If this did work, you're kind of saying that you can't read the string out, is kind of what you're saying?
I can't do something like this, given a secret. Right? If I write this, that means, well, I got my secret here. And I don't want that. I would want the secret to be generated by some, I don't know, some secret manager service like Vault or something like that.
Like it has escaped its scope that way, right? Because you're returning it.
Exactly. And what I would like to be able to say is, no, secrets only exist here in the scope of with secret. So you can interact with it in the function that you pass. You can, for example, use it to put it in an HTTP request to Vault, and Vault is going to say, that's actually a valid token. That's what I was hoping to see. Here's your key for this interaction.
But doesn't that mean if I have to pass it in, I kind of have a reference to it already?
You call with secret, but with secret is implemented for you by somebody else.
Okay. So it's the random number generator. We're not passing random number. He's doing the random.
Yeah, exactly.
Number.
So it might even be somewhere in my program, I do have that. Maybe even it's in a library, but at least like I know that if I only have the with secret thing, then I can't really. Okay, I see.
That example, I didn't think it through all that much. I just wanted to say, I have a secret. I don't want it to escape. Mm-hmm. Of course, I mean, you could also be creative, right? You could do that. So this example is not perfect. I'm just showing there are valid use cases for wanting to to prevent capturing of stuff that are not capabilities.
Yeah, and I mean, there's always ways out, right? Like you can always cast things or whatever, right? Like
no, you can't. You can't cast them. That's the thing.
No, I mean, like if we're trying to be super type safe everywhere, right? So we try to do things right, but you can, like, if you want, obviously, you can still as instance of something to something weird, right? The println thing could still work, right? That's what I mean. That's a weird way of doing it, right?
In theory, you can't escape. In practice, I think it's called unsafe as impure, which removes the capture checking. So it exists.
Yeah, like these. If you escape, then you can call them prompt injections, I guess, right? Because the things are called prompts.
You, sir, are making terrible jokes about topics that should not be laughed about.
Okay, very interesting. But I guess Jay wants to close the parentheses and know why it's a problem for the.
But before that, I think think we should have looked at what our capabilities are, maybe, or go back to your example where you showed us rand and something else and tell us a bit more about that.
I can talk about capabilities. Yeah, I can tell you the idea of capabilities, but it's really just, again, a disagreement with Martin. Capabilities, in my mind, are a weak form of effect handlers. And I had an entire talk about that. And just before I went on stage, I had a chat with Martin. I said, and I'm going to talk about how capabilities are a weak form of effect handlers. And say, they have nothing to do with effect handlers. It's completely unrelated. I wish you'd waited until after the talk to tell me that, because this is sort of making me lose my confidence now. But I disagree with him. I thought about it quite hard, and I disagree with him. So I think, Martin, how comfortable are the two of you with effect handlers and algebraic effects?
Yeah, as long as we don't have to go like F monad, I think I'm okay.
We don't have monads. And this is one of the spicy takes that I have that I think Jay wanted me to get into, where we get referential transparency. That's overrated. So algebraic effects are a way of encoding effects in your types and providing different handlers for them that don't involve monads. And you have a variety of effects that you can handle. This is my vocabulary. I don't think it's official vocabulary, but I split them in two categories. I have control effects and state effects. State effects is what we call side effects everywhere else, right? Is whenever you mutate some global state or some non-local state. And control effects are when you have the ability to change the control flow of the program. Typically, an exception is a control effect, because if the exception is thrown, then it interrupts the regular flow of the program to go to your catch point, right? So that's a control effect because you change the way the program flows. And algebraic effects allow you to write both kind of effects, and capabilities only allow you to write state effects, not control effects. Does that make sense?
I guess, yeah.
Can we look at the example of what it allows? Like we can look at the rand and maybe after that mention what it does not allow?
What it doesn't allow is going to be hard because in Scala we don't have the notion of continuation, so I can't really show what doesn't exist.
Just talk about it, like maybe something that you would want to implement, some example.
Rand is a shared capability, and then I provide a bunch of handlers, recorded being the most interesting one of them all, and then a bunch of operations, so ASCII printable car, ASCII car, which those are all based on the Rand capabilities. This is what that means. And then when in my test, then I can just use them. Right, I can just say alpha car or list off. I can just use them. And I, as a writer of the code, I don't care about how it's implemented. I'm describing the semantics of my code. I'm saying, here, I want an alpha upper car. Here, I want an alpha lower car. You deal with it. Now, the advantages are they're tracked in a type system. Because really that means the type of that is really roughly right? That type. So it's a function that takes implicit random size and returns a string. And there's a zeta expansion, so it transforms methods into context functions and context function back into methods. But anyway, that's really what you're working with, is a function that takes a random size and returns a string. And so you have encoded in your type the effect that you're running. It's right here, this random size. So in your type, you know which effect a computation is going to run, which is pretty neat, because that means it allows you to reason about things quite clearly, because you know exactly what can happen and therefore what cannot happen. So for example, if you go with the other way that we do effects in Scala, cut effect, we're going to say, well, we're going to check everything in IO. So this is going to be IO of string. Mm-hmm. I have no idea what effect it's running. Might be running no effect, all of the effects. I don't know. IO is not granular. It's just saying this is effectful and I don't care about the effects. Here, I'm stating I know exactly which effects are going to be used. And we have something called effect safety, because I can't call rand of name in a place where this is not available. So if I'm outside of the scope of something that provides these capabilities, I can't call it. So it's impossible for you to rely on an effect that hasn't been provided. This may not sound like a big thing, but in OCaml, for example, where they have algebraic effects, they do not have type safety, which means it's perfectly possible for you to use an effectful operation, such as alpha uppercar, the compiler to accept it, and then when you run it, you have forgotten to provide a handler for it, and then you code dump.
There's one thing that I have trouble with seeing here is kind of how this is different from just saying def ran name and then requiring like two traits, one being like rand and one being size. And then I just kind of, these are side effecting things, but they do exactly the same thing.
So I can answer that in a cheeky way. I can tell you that in Scala, we have a weird quirk. We hate passing arguments to functions. We hate being explicit about it. So we have
I think that's
these
JVM
things.
thing, not just Scala.
Right, on the JVM, we don't like passing arguments to functions. So in the Java world, we have Spring Boot, right, where everything is wired at runtime. In Scala, we're a lot more principled. We do it statically. We do it at compile time. But it's still the entire point is not to have to pass them. How is it different from what you're describing? It's just, I don't want to have to do that here to pass this absolutely everywhere. It allows me to write this code exactly like I would if I was writing imperative code, in which the effects that I'm using are not encoded in the types. This is the exact code I would write if rand was just a global effect, but it's still encoded in the type. So you take an imperative bit of code, and thanks to implicit values, you can change the types of your program without changing the terms of your program. And you get something that is no longer imperative because it's everything left and right. The effects are encoded. You know exactly which effects you're going to run. You can't run any effect in your code. So you have changed the types in order to encode your effects, but you haven't changed the terms, which means it's very comfortable for any developer to write the code, because you can just write the code that you've been taught to write in high school. You can write C, right? But the types prevent you from doing anything stupid.
I think I get it, but couldn't, like, if rand and size were just like type classes?
A type class is a type hole, right? What's T here?
Does it have to have that?
It's not a type class, it's just an implicit parameter, and this is exactly that.
No, I was just wondering, right? Like, I'm just thinking back to like you said, right? Main reason is you don't want to spell things out, and then what you do in Scala is you call it implicit once, right? And then you kind of do that. And then I was thinking using is kind of the new implicit, but I thought it was for type classes.
No, it's exactly the new implicit.
Then I was just wondering, why couldn't this, okay, then let's not have it be a type class, but just like an interface, like a trait, right? So if rand was a trait, like I'm wondering, why do I need this fancy arrow stuff and so on?
What do you think that is? Rand is a trait.
So where does the arrow come back in?
So you mean the slightly confused
that one.
Oh, this is just saying what's on the left side is implicit and what's on the right side isn't, right? So this is saying it's a function that takes an implicit rand and returns an int.
Oh, okay.
By opposition to this, which is saying this is an explicit rand that returns an int.
Okay, so it's just more convenient syntax again.
Or
could I not express that before capabilities?
You could not express implicit functions before capabilities. Scala 3 offers you a bunch of new stuff on functions. So you can have function with implicit parameters. You couldn't have functions with implicit parameters before. You could have methods with implicit parameters, but not functions. And you could have polymorphic methods in Scala before, but not polymorphic functions. So you couldn't write something like, given some a, I'm going to return an int, right? This is a polymorphic function which works for any a. You couldn't write such functions before. You could write such methods, but not such functions. But it also has special handling in the compiler, which brings us to something I think Jay wanted to hear about before, which was doing and being. So,
but you also mentioned that we cannot express the control flow thingies with capabilities. Directions can we go through?
They're forks in the road. They're completely unrelated, actually.
Can you cover on the previous one? Like example of abilities that you would want to express, or example of ability, for example, in Unison or in Franks that you could do it, but you cannot do it with capabilities.
No, it's not weird at all. How do you think exceptions work, for example? How would you encode exceptions in Scala if you didn't already have exceptions? You couldn't. So Scala, that's another point that I like to make. Scala does not allow you to do control effects. It's not that big of a deal because we already have most of the control effects we need built inside the language.
And with monads.
So monads are super powerful. You can implement everything with them. It just has a massive cost. But monads, I mean, if you have the free monad and co-products, then you can implement everything I've just told you about. You can implement them directly in the free monad, and it works great. It's just so complicated. So much cognitive overload of the syntax you have to learn and the type class. It's so hard for beginners. But monads work for that, absolutely. Typically, I/O, which talked about before, allows us to do fibers, right? It allows us to do user-level threads. And it does so because it's a monad, and therefore it allows you to store the continuation in memory and reschedule it. You can't do that in Scala natively without using monads. We don't have to because Loom allows us to do it. So it's natively supported by the language, but if it wasn't, we couldn't implement it without monads. With algebraic effects or effect handlers, really, you could implement it by hand. The way it works, for exceptions, I'm going to make syntax up now because this doesn't exist. I'm going to call it error for except. I'm going to call it exception, which extends shared capability. It has a single method, which is raise, so it's not a keyword, and say an error. Don't care, right? Then I would have to write a handler at some point. So the handler would be a handler. I'm making syntax up here. So that's going to be basically a pattern match, which is going to be case value of x. I'm going to explain that in a second. And case raise of MSG. Do something. We'll see what later. So the handler, this is telling me if in my computation somebody has called that, this is the code that's going to be called, right? How could you implement that? So let's do handler of if true, then raise was true, else return 2. It's not the most useful computation. It just fails all the time and returns true. But this has type int, doesn't it? Because this returns 2 in the end. I'm going about this the wrong way around because this is a complicated. Let's do read, which has the read, which no parameters, return a string. And then handler of read would look something like this. Case read, get the continuation, and they had hard-coded it to foo, right? So to explain what I'm doing here, if I encounter read in my code, I get the continuation, and I'm going to call the continuation with whatever I want to read. So the continuation allows you to say, right, I have been asked to perform the operation read, and once I have computed the result of that operation, I'm going to pass it to the continuation. In the case of an exception, the way you do it is by not calling the continuation. So the only thing you can do is fail, since you can't possibly call k with a value because k is going to take, as we've seen here, an int, but you don't even know the type. You can't provide a value, so you just ignore the continuation. So the way effect handlers work is by giving you access to the continuation, which you can ignore and not call in case of failures and exceptions. You can call once, exactly once for, typically for read, for example, you call it exactly once with whatever was read, or you can write generators that way, you can write fibers that way, or you might want to call it multiple times. In that case, it's a multi-shot continuation. I think the only case where that's useful is when you're going to do backtracking. So you could write a parser combinator that way, right? Or say you explore a tree of integers and you want to try all of the possible branches. You could call the continuation on the left-hand side, and then you get the maximum value of that side, go back up here and call the same continuation on the right-hand side, get the maximum value there, and then you compare it. But basically the idea is if you have the continuation, you can choose to call it 1, 0, or many times. And this is how you change the flow of the program. And in Scala, you don't have access to the continuation, so you can't change the flow of the program. You can sort of cheat because we have exceptions. So we can throw an exception and say, actually, I'm going to prevent the rest of the code from being called because I'm going to throw an exception, which is roughly the same thing as I'm not going to call the continuation. But I can't call it multiple times. This is how fibers work, right? The continuation, once you've run your chunk of the fiber, you have the continuation, you store that in your scheduler to be called back later. Scala does not give you access to continuations. Can't do continuation. You can't do fibers in vanilla Scala. You can do it because of Loom, or you can do it with IO because IO. You know when you do flat map of F, well, F is a continuation. You have it. It's a value. You can store it. So that's how it works. But in Scala, you don't have all that. I'm going to delete that code because it's dreadful. I just made that. So very, very
Okay,
bad.
I think I get it. So with the promise of algebraic effects in the papers and unisons and stuff, they give you access to the continuations because
Absolutely.
they give it to you. But IOs and Monads give you kind of access to stack or also continuation, so you can do it as well. But with capabilities, they don't give you access to any of those abilities. Don't give you access to this, so you cannot do it. They only give you access to like state and other stuff you can already do with implicits. I see.
Which is what I meant when I said I see capabilities as a weaker form of effect handlers.
I see. Or not related to effect handlers.
Martin said it's not related because Martin, the impression I got, not to put words into his mouth, but the impression I got is Martin saw effect handlers as mostly used to do control.
Yeah.
And in that case, yeah, absolutely, capabilities are not at all effect handlers because they don't allow you to do control.
Yeah.
But it's not how I understand algebraic effects or effect handlers. Effect handlers allow you to encode control effects, but state effects as well.
Yeah. Okay. But also, it's not a good marketing to call something a weaker form of something else, right?
It's not. And at some point, I actually had.
I mean, sorry, but like there was this big, for a few years, everybody was like, why are you using monads when you can use applicatives? They're so much weaker, right? So I think in some cases, you can argue that works on people.
But marketing for monads and marketing for applicatives is not really good marketing, as we can see people not being big fan of either. So I don't think that it really counts.
I don't know if it's true that people are not a big fan of either, because when I started working with capabilities and when I started playing with them, I thought, oh, this is great. I can do all the stuff I did with monads, but I don't have to pay the monad cost. I don't have to learn all this horrible syntax on top of it. I don't have to call flat traverse ever again. And I thought it was brilliant. I absolutely loved it. And I started talking to people and everybody basically went, yeah, but it's not referentially transparent, therefore it's rubbish. It's not pure, therefore it's rubbish. End of story. So people love their monads. People love it. And I understand there's a lot of good things to say about monads. It's just, I don't understand his argument that if something is not referentially transparent, then it must be useless.
Can we look at the test that you wrote and see it as an example? I think we can look at the random name, right? Like if we generate two names, we can see this, and then maybe we talk about it a bit more, because I think it's interesting, something to focus on.
Let's change the test then. Let's do something like user1 equals user of name 18, user2 equals user of name 18. So clearly this should pass, right? This user1 should be equal to assert equals user1, user2. This should pass, right? That makes sense.
Yes.
I'm getting a random name, I'm using it. And if I run that, I hope it passes, otherwise I'm going to look like a fool. Wonderful. It's a hard thing to say referential transparency for a Frenchman. I'm going to call it RT now, okay? It's a bit of a mouthful. So if rand name was RT, the property tells us I can swap it. I can swap the expression for its name without changing the program. So I should be able to do that. And that should be exactly the same program. It should behave exactly the same. And I mean, there's a chance it might be the same. No, there we go. See, the first one was AA. So it's not referentially transparent because if I call it twice, I'm going to get a different version here. So it's not referentially transparent. Effects, algebraic effects, capabilities, all that, abilities in unison, all that family of things, they are not referentially, they're not RT. And they're inherently not RT because whenever you use one, you run the effect. So running the effect is not RT. Just like with IO, when you run IO, it's not referentially transparent because whenever you run it, if you run it twice, you get two different results each time. Because that's what an IO is. Creating the IO, that's RT. But then when you call unsafe run sync, then you get a different result each time if you're doing random numbers, for example.
I think this is pretty bad. So I think like one of the things that, for example, here, the visual wise, it's the same, right? When I look at rand.alpha upper character, for example, I don't know if it's going to run something or not. I don't know if rand name means it's going to run something or not. And if it goes back to all the discussion like like, is it going to launch missiles or not, right? Like maybe I can look at the function signatures, but if I don't see the function signature, there is no special syntax like exclamation point or explicit parentheses. I'm looking at this and I don't know. So in cases like this, the loss of referential transparency, it's looking scary to me.
But if you stick it all into IO, as you would as an alternative, you just have the same thing, but more syntax around it, right?
Yeah, that's, yeah.
Mark, this is an extraordinarily important point. You're completely right, but most people just entirely fail to see that. When you create IO, creating IOs and combining them, that is referentially transparent because you're not running the effect. You're just creating a program that you're assembling. You're not running anything, so of course it's pure, right? But when you run it, then all these weird state interactions that you have when you're writing imperative code, they happen inside of the IO. You still have to make sure that the right effects happen at the same time, the right states are mutated, then everything works out. You still have exactly the same problem, don't you? In IO, it's just, there's this thought that since IO, a value of IO is referentially transparent, then it's a lot easier to reason about. I don't think that's true. But it's exactly the same problem, it's just choosing to ignore it.
Yeah, it's gonna explicitly, okay, I see IO, I don't trust it. But in this case, I'm not sure, should I trust it or should I not? It's the approach.
That's one of the problems with the Scala approach to effects, and it's not related directly to capabilities. So I'm going to write some code and you're going to tell me what you think it does. Where this reads a line from standard input. Now, how many times is read line called?
Oh, one time.
No, it's not. It doesn't matter, right? Who cares? It could have been what you said, and my answer would still have been, I could have guessed. What I'm trying to say is, you don't know. It could be either. You have to go look at the types. And that's part of the design of Scala, where they will transform computations in values or values into computations depending on the context, because the compiler is often smart enough to realize this is what they meant, and therefore I'm going to make them happy and do it. But sometimes it's not what I meant. Sometimes I made a mistake. This should not have compiled. I didn't mean to apply my computation. I meant to store it somewhere. And so in Scala, it's not an inherent property of effects or algebraic effects or effect handlers. So in Scala, we blur the distinction. This is a point that Jay, you wanted to talk about earlier, about being and doing. In Scala, when you look at something, you don't know whether it's being or doing. You don't know whether it's a computation or just a value, really.
So in this case, we don't know if read line means read line and then put it 10 times, or it means read line 10 times, right?
The problem is list.fill. You don't know if fill, let's say it's like that. You don't know count int, and you don't know if it's, let's do strings for the moment. You don't know if it's s string or if it's
the unconfused arrow.
Yeah, which one is it? If you don't have access to that, you don't know. I can't know which one it is. So I have to go look at the documentation or the code if I have access to the code and see, oh, that's a by name parameter. So this is going to be called every single time. It's not to do with readline, it's to do with fill itself, where I was allowed to locally override, because Scala is a language that is by value most of the time, but locally I can say, actually here it's by name. And that is a problem. And we had exactly the same thing for capabilities, but it's the same problem. Does that make sense?
Yeah, I'm just thinking that most of the solutions are to just not use these things, right? Like, if you use IO, you don't need that arrow thing anymore, right? So
no, you're right. So it's always a matter of trade-offs. Yeah. I am not here trying to say capabilities are inherently better than monads, or vice versa. I'm not either saying that monads are always better. I would argue that monads IO is strictly more powerful than capabilities. You can do more stuff, if only because you have access to the continuation, because that's what you pass to flat map, so you have access to it, right? So monads are inherently more powerful. You can do more things with monads than you can do with capabilities. However, most of the time you don't need to do these things. Because, for example, one of the really cool things about having access to the continuation is it allows you to do non-blocking I/O. It allows you to do fibers. Monads allow you to do asynchrony in a language that doesn't support it natively. But Scala does support it natively. We have Loom, so we don't need monads in order to achieve the same effect. So yeah, monads allow you to do it. This is brilliant. They allow you to do it. They allow you to do quite a good job of it. I mean, I/O is, by all reports, quite fast, quite well implemented. So it is possible. It has been done, and you can't do it another way in Scala at the moment, except it's natively supported, right? So yes, monads are strictly more powerful. They allow you to do stuff that, for the most part, you don't need to do because it's already supported by the language. So it's a big advantage. It's strictly more powerful, but that power is not necessary. And that power has a cost. Because, right, a very easy example, but both of these things are integers. If I'm doing it in direct style, if I want to add the two of them, this is what I write. Yeah? Easy. If I were to do it within a monad, let's say option, let's say I/O, we've been talking about I/O. Then I have to do a.flatMap, b.map, a plus b. That is a lot harder than a plus b. Right? So you have to remember that use flat map and map. You have to remember, oh, and the last one I have to use map and not flat map because reasons. You may argue this is manageable. People can manage that amount of complexity.
Oh,
I
that's
think
my
it's
main
manageable
argument.
as long as you have like I/O unit, but the more you get into productions, usually you have like I/O of either int, and then that's not manageable, definitely. Like
And then
I have
it's-
plenty of experience already, like 10 years with transformers and MTLs and stuff. It doesn't get better.
Jesus Christ, Transformer. But so Transformers work, right? The MTL works. It's just a bit archaic now, but it does work. It's just the cognitive cost of it, the amount of shenanigans you have to do, the amount of things you have to do to appease a compiler in order to get properties that you might not care about that much when there's other solutions to the problem you're trying to solve. So I'm not saying monads are bad. I'm actually saying they're really good because they're very powerful. They can allow you to express anything, but they have a cost. And for most programs, I don't want to pay the cost to do something that I'm not going to do. I'm very happy to lose referential transparency and the ability to work with continuations in order to make code that is maintainable by human beings.
What about, like, I was curious because you were saying kind of you have these control things that monads do. And the first thing I was thinking about was what you just went to, which was option.
Yeah.
Is that something you cannot do then with capabilities? Or is it just doesn't really make that much sense? Because like to me, that's like if I think of monads, you know, you don't always have to go straight to I/O, right? Like you can think of things being nullable or whatever, right? As the first step. So I'm wondering, because to me it's control flow, right? It's kind of early return, I guess.
That's not how I see it. To me, optional is not control flow. It's do I have a value or not? Which is not quite the same thing as I want to continue or not. Now you can use it to do that.
But the
then you have to
monadic
edit it.
thing of option means that implicitly, if you don't have value, you stop, right?
Right, but then you can absolutely have some sort of capabilities.
I think the interesting example, like in Unison, they have optional is just a data type that has map and other things that you can use for the values, but they have exception or whatever it's called that you use for control flows. One is for control flow, and the other one is just for normal data. I think it's kind of annoying in the beginning, but I think you just get used to it and you treat optional as just data type and you treat the control flow as something else.
And actually, the question mark can be very easily implemented in Scala with capabilities. But to answer your question mark, could we do optional?
It's very good. I like it.
Yeah, like question mark?
Oh, I didn't. Sorry. But
That's fine.
I'm going to do it again because that was good.
I used to be a currency, right? So I'm fine.
Right. If you want to use option as a control flow, that just means in the case of the option, you say a dot map +1. That's just saying ignore the continuation if a is none.
Mm-hmm. Yeah.
So if you had effect handlers, well, you know, at the handler, you have the continuation, you just don't call it. It's the same thing. If you're in a language that has access to the continuations, you can do the same thing as with monads.
Yeah.
Did you want me to show you how to implement question mark in Scala, or is that just not that well?
To me, it would be interesting.
We started, no, that's, yeah, that might be the one.
So
An
you have
example.
like a whole repository of things implemented.
Well,
there.
it's just me trying stuff for fun.
Yeah.
But typically, you know sequence, right?
Yeah.
Sequence is where you have a list of options and you get an option of list.
Poor man's traverse, right?
Exactly. Well, here to have it with option, right? So you can implement sequence like that.
Well, I have to. I'm still thinking about
What's
it. So
the
you have
option
the question mark.
column in there?
Ah, that's a prompt. That's a prompt that's telling you if you encounter an error, use the option handler. If your option, your OAS is empty, then that's going to raise an exception. Sorry, OAS is a list of options. So you map on it, and for every single option that you find, you're going to unwrap it, right? And so if that fails, that's going to throw an exception, which here is called break. Otherwise, it's just going to unwrap it. And then in a handler, which is here, you say, well, work on that. And if it's a success, you wrap it in an option. Otherwise, for any error, you return none. And so here what happens is if everything is sums, then you get, this is going to wrap it in an option of the list of the unwrapped values. But if at any point you find an error, if one of them is a none, then that's going to get into that case and you get an overall none.
Okay.
And so you can absolutely use capabilities to implement this kind of workflow.
Okay, I see. So, I mean, I think I'd have to
step
up my prompt engineering game before I can get the syntax right.
Mark,
No,
you said
honestly,
no
that's
LLMs. We clearly said no LLMs today.
I mean, but honestly, I think the syntax is still a bit, and I think internally you have this question mark thing, right? You have this throwing, right? The break thing. That's something you defined, right? That is within your algebra of things that you can do in there, right?
I mean, I can share that code. It's basically very simple Scala. Once you know the syntax and you know capabilities and capture checking, because there's some capture checking shenanigans going on. So basically there's a lot of knowledge to have, but once you have it, it's quite easy to go through. And credit where it's due, this was inspired very much a re-implementation of something that Ricardo, the maintainer of yet another effect system, Yes, is doing. So he's basically re-implemented Kotlin Raise and wrote it in Scala, and this is basically, this is very clever, let me do it again with my own words, and this is what we get. I think it's now implemented in the Scala standard library and the control package.
But maybe getting back to Jay, your point, I think maybe
purity.
Yeah, I'm thinking there's kind of a middle ground, right? Because you can say that at least your stuff is tagged more granularly, right? So it's kind of harder to see maybe where something does happen, although if it's called rand dot something, I mean, it's probably not that hard to figure out.
The issue is that you see it on the types, right? And if you look at the types, but it's here, if you look at the GitHub or Codeberg or just in the README or in whatever, it's hard to see on the value level, on the text itself, on the syntax level, is it going to be doing something or not? It's maybe we're going to adapt more strategies, have exclamation points on that. Something like this. One other example that I'm looking at Zeek, right? They have IO and allocators tracked, but not by the type system, but you pass it as a type, as a parameter. So if your method or function takes IO, it's probably going to use IO. And if you pass it further, then it's probably going to use IO. So there is a marker, not in a FT-way marker, but it's a different marker. And I'm kind of okay, it is also purity. It's also referential transparent to the way. But I'm this is also works. At least visually I see it. I'm maybe that's a way to approach it as well, but just kind of missing something.
I have two answers here, two parts. One thing is, you said it's encoded in the type. With capabilities, it's fully encoded in the types. It's at the term level, sometimes you don't see it. And I agree.
Yeah.
Now, in Scala, when you're using IO, if you have a value that's in IO, fair enough, you know it's going to be effectful. But inside of your IO, you don't know whether the values are effectful or not.
But if I have for comprehension, I'm going to see bind versus normal lets, and I'm going to see flat.
No, I'm talking about what goes inside of the IO.
Okay.
And inside of the IO, print line foo. Do you have any idea whether it's effectful or not? I mean, you do because you know the function, but if you foo of bar, is that effectful? You don't know. You have no idea when it's going to run an effect. You have to keep track of that. Inside of the IO, everything is horrible inside of an IO. You have to do all this to pay attention to all these things. But most people go pretty much like you just did. It's an IO, and I can compose it with flat map. Very true. But what goes inside of the IO? That is effectful. That you have to pay attention to the state. That you have to do everything you have to do in an imperative language. So IO, you get the fake impression that it's all better because when you create your IO, you can compose it in a way that's very convenient if you know the language. It's very neat. It's got lots of very useful combinators. I am not at all disputing that. And the very good libraries have been built on top of it. But then you say, and it's fully referentially transparent. That is a lie, because IO is two different things. It's declaration and execution. Declaration, referentially transparent, absolutely. Execution, thank God it's not pure, because if it was pure, your programs would be useless because they could not produce any side effect. Right? So it's not better.
I think I'm not going into better or not better. I'm kind of going into like, is it enough? It's sufficient enough for me to be like, okay, I kind of feel comfortable with this or something along those lines.
I don't see how it's different. Once you start talking about execution, I don't see how it's different.
Usually execution is quite far. Like most of the codes that I'm looking at is not execution. Like 80% of the code I'm looking at is about just declaring stuff. I'm not looking at execution, or like ignore execution. And then when I look at execution, then it's all hell breaks loose, yes.
But the computation you put inside of IO, you write them yourself, and these are stateful, but you still have to write them, and you have to pay attention to the state when you write what's inside of the IO.
Yeah.
Yes? If you have an IO that prints to standard output and another IO that reads from standard output, right? Yeah. And you want this one to happen before this other one, then you have to pay attention to that. You don't, for free, get, and everything is going to work out in the right order, even though I don't tell it anything. No, you have to be explicit about sequencing.
100%, yes.
And so sequencing with Monads has a massive advantage. It's very clear. It's very obvious how you sequence things, because that's bind, isn't it? That's flat map. When you do A bind B, it's very explicit that you run A and then you run B with the output of A. So sequencing is very explicit, but it's also very explicit using direct style. So you don't gain anything here. So my argument is basically this. When you talk about purity and what it buys you, usually people say, well, there's two great things about purity. The first thing is it allows you to use, how is it called again? The substitution model, which is what I showed you earlier, when you can substitute the expression by its name and that doesn't change the behavior of the program. This thing is absolutely correct. It allows you to do cool refactoring in a way that always works if your exceptions are pure. It's just a refactoring. It's really cool, but it's just a refactoring. I like to have it, but not at any cost. And the other thing that people say is purity, referential transparency, is easier to reason about, or I think equivalently, purity allows you to do local reasoning. And I think this is completely true, but not for Monad, not for IO typically. It's true for, it's basically what you do in functional programming, isn't it? You prefer immutable values, and so since everything is immutable, then you don't really have state, and it's very easy to reason about because states can't interact with each other. So that's true. But in the case of IO, the entire point of IO is side effects. So if IO is all about side effecting, then you don't have this advantage, right? Because you're going to have the side effects. At runtime, you don't have them when you declare and combine your IOs, because those are suspended computations. But when you run them, then you have all the messy side effects, and you still have to think about that. So I don't think the advantage is that massive. It's not nil, it exists. But I don't think the argument that, it's not referentially transparent, therefore it's crap. I think it's a trade-off.
But to me, honestly, it's also a bit about what syntax the language gives you, right? Because you just showed this flat map stuff. And that, to me, is one reason why I very much disagree with people saying you can do functional programming in any language. Because I hate this. Like, I don't ever want to see this. Like, I want whatever, right? Like, it's just words that I have to read. But in the end, I just want to pipe my data through, right? And then I have to, like, ignore these words. So that's better, right? But it's still pretty shit in Scala, because you always have to have this yield thing. You always have to have the arrow, right? So if I'm honest, if I have something like Haskell where I just write do, and then I can write my print line or whatever.
For yield is the same thing as do return.
No, but like, no, because you have to have the arrow, so you have to have underscore arrow and then say print line, which is confusing. Why do I have to do that? I have to
No, you
always
don't.
yield
Actually,
something.
this is even worse than what you're saying. That doesn't work. That's not going to compile.
Yeah, because again, in Scala, you have print line, which is typed wrong, of course.
Right. Okay.
But,
So print line return. No, yeah, you're right. Sorry, you're absolutely right.
so that to me plays a big role, and that's why I think maybe in Scala, because honestly, like I think Martin is kind of a little rock star, right? Because I think in the end, he tries to do things differently from everybody else, right?
He's punk.
But then the problem is a lot of the community, they're like, oh, we like this stuff from Haskell. Let's build this type class thing. And it's kind of how it goes, right? They just try to, oh, it's super powerful, right? I don't know any language that is more powerful, right? Like it has crazy type system stuff.
I don't know, TypeScript is quite
yeah, but I don't know if that counts.
So
counts
TypeScript is really powerful, but the type system is unsound, so I don't think it qualifies.
it's scarier.
Yeah, but like that is that such a great point? It's like then you should have never used Scala too, right?
No, you're just
Your
being
tasty
rude.
thing is proven, right? Like, oh, phew, we got something on TypeScript.
No, hang on. I think Scala 2's type system was sound. It was the macros that were not sound. Wasn't the type system sound?
I don't know.
Type protection, you're right. Scala 2's type system was unsound, but we choose to ignore that.
Yes, exactly. We don't want to ignore it in TypeScript. I think that actually makes a big difference. And if this is easy to use as syntax, because that's what you were also motivating this with, right? Like imagine you are a beginner and you have to read that stuff. There's so much weird things, even
Absolutely.
with the 4 comprehensions, in my opinion, that like, what
agree.
do I yield? I yield another unit, right? Or like even, I want to just stick something in a monad. What do I do? Like .pure with some cats import and then like pure the thing that I have set as the return type anyways, but variance or whatever, right? Like it's so hard.
I completely agree with that, which is why I think I like capabilities better than I like monads, even though I will agree that monads are strictly more powerful.
So I would think maybe it's some kind of, bit of a gateway drug thing where you get people slowly into being more typed, right? And not have effects or side effects willy-nilly, right? You start with this and then maybe they hit the referentially transparency thing at some point, and then you tell them, yeah, because of this, and then they can make the choice, right? And I think also testing is a really great use case for this, because that was one more point I want to make, which is, with monads, I think there's I don't know, I never really read papers, but I think for monads, there was the Waddler thing, which was about like, oh, look at all these imperative things that we can now finally do if only we have monads, right? And then you have reader monad, state monad, and writer monad. And one thing that it is sold as, if you're still learning it, is that the whole writer monad thing, that's just like a logger, right?
It's a bad logger.
Yeah, exactly. And that's what I was trying to get into, right? Is that you have state, which is, it's a cool state thing. And I think you've shown us something that's pretty much like state monad before, right?
But pretty much, yeah.
Yeah. And the point is that you try to use it as a logger, you run out of memory, and your big old thing, nothing got logged, right? Because it didn't get to the point where you wanted to log this. So then you kind of cheat a lot of things, right? Like reader, you can use it as like whatever, some dependency injection, but you still don't really use reader like that in Scala, at least, right? And I don't think in Haskell either. So a lot of these things, they kind of get subsumed by a lot of IO thing, right? It's just use, maybe don't use state monad, you use ref inside of IO, right? And then you use this and that inside of IO. And you could argue that in a lot of this web stuff, right, like almost everything becomes an IO thing. So always happy when you find one pure function where you're like, oh, maybe I can write a property-based test for this thing because it's kind of pure and I can afford to run it 100 times or whatever. So I'm thinking that's maybe in some cases, you prefer these practical things, like let me just print something to stand it out now, right? Like let's not build up some logger and pretend I have infinite memory and nothing ever happens.
I must print into outlines in your test. Like you still have kind of this problem somewhere in the tests, right? Like if your functions are not pure, your tests are going to be...
Get the print capability, which offers print line. And then I can provide a handler that ignores print line for tests, for example. You can do with capabilities, if you're not talking about control effects, those are right out of the window. But if you're talking about state effects, which is a lot of them, really, then you can do them with capabilities, encode them in a type, and provide whatever handler you want.
Mm-hmm.
Can you imagine doing that with Monads?
I mean, I can imagine a lot of things with monads, but yes.
Can you imagine how different it would look than the very simple code I get to in the
Yes.
end, where
Yes.
random
Yeah.
number and then just a loop, right? Just
Yeah.
recursion, but yeah. With Monads, chuck everything into IO, brilliant, but then IO is really all of the effects, no granularity whatsoever. And therefore, when you have an IO value, you don't know what it's going to do when you run it.
And maybe also sometimes the other way around, right? If we're thinking of the logger example, maybe you do have some code that is actually pure, but you kind of want to log something maybe. It's not really nice to have to stick that into IO, right?
So while I agree with that, capabilities do not solve that problem, because I would have to say, I need to get a logger.
Yeah.
It would change the type. It would not change the terms, but it would change the type.
No, but I think it's still fair, right? I think it's a really good case where you see, okay, it just does logging, right? But it doesn't do all of IO, right? So that's like...
Exactly. Capabilities are very granular that way. Let me show you an example. This is the type of a test. And
you can't compose them, right?
You can. I can absolutely compose them. But in the case of test,
it is this. Okay, I see.
A type of a test takes... All my tests always take all these 4 capabilities.
Yeah.
So it's a bit of a mouthful, say assert, log, rand, size to unit. So you end up having massive long strings of capabilities that you're using if you're doing anything quite complicated.
I'm not sure I understand. Like, I mean, you can, how do you compose them? So could I say, like, I have an alias for assert and log and one for rand and size, and then I can kind of combine them? Or I guess I always have to make a new, so kind of composing like almost like monad transformers.
No, they're not.
Ad hoc.
You just add a new parameter to the function, and then since it's filled implicitly for you by the compiler, you don't have to change anything else.
I was thinking maybe I have like a nice little alias like you have for just assert, log, and rand, and then I have one for log, rand, and size. And I just want to like maybe plus these together and ignore the like whatever the duplicates
I guess
are,
what he's saying, like, can you do type test 2 that equals in parentheses like this? And that's it. But then the part on the right, I mean, like, can you remove the unit and the confuse arrow?
Yeah. Oops, sorry.
Like this part, can you put now test 2 inside the test? I think that's kind of the question.
No, because
like, can test be like test 2, comma, assert, log, rand? Like, can you compose those things?
I mean, first, that's a tuple, whereas a test is a function. So no, you can't use that, right? You've declared a tuple assert log. This is not a function type.
But could you add like an A to the test2 thing that it takes as like input and then put the arrow back and just say it goes to A? Probably not. You're not looking like this and then question mark.
No, I'm just trying to understand where this is going. Yeah, you can absolutely write that, but you could not pass that as a test because
No, not necessarily as a test, but like just anywhere.
I think both are fans of pure script and raw polymorphism, and the things that we do there is kind of a lot of this. You have one type, and then you extend the type with a type, and then you add more type and type. I think that's kind of Mark is leading into, right?
We don't have raw polymorphism, so what you're describing is not what we can do. However, you can absolutely pass here, if we had that to make it easier. I can pass a test 2 where a test is expected. That's fine. You can pass a computation that requires fewer capabilities where one that gets more is expected. It's the other way around that you can't do it. I can't pass a test where a test 2 is expected because this requires more. But that, I mean, I need an assert and a log, and if you're going to give me a rand and a size, I'm just going to ignore them.
And one thing I was worried about in general is like, let's say this takes off.
Yep.
It's probably more of a general Scala problem, is that it would be probably quite nice, like in the sense that none of this is really first class, right? It's not like there's a standard library and it has, I mean, more like you can do stuff with monads in Scala, but you need something like cats, right, to give you the type classes that maybe you care about. And then it's ideal if maybe everybody who implements an applicative doesn't have their own abstraction for an applicative, right, but reuses the cats one or something. And that's what I'm wondering about here as well, whether it would probably be nice for composability as well, right? Like if I want to use your testing library, and then I want to use some other library that uses loggers, that they use the same log capability.
Right.
Okay.
Let's look at the code. So where is it? And somewhere in there, one of these things is a capability, but I forget which one. There we go, that one. Labeled as a capability. So you already have capabilities free in the standard library, and boundary break, which is basically how you do control flow with capabilities, is already part of the standard libraries, but it's also trivial to write your own for your very specific thing. And it's very easy to transform one capability into another because, again, it's just a matter of writing the handler. I can take a handler and transform it into another one. Okay, let's pretend. I have two traits. Print, which is a capability which has print line, gets a string and prints it. And then I have another which is read. Def, read line, returns a string. Well, the handler, I could create a new capability, console, tty, which is print with read. And so this is a new capability that subsumes both of them. And this could have additional things such as set color, set foreground color. Right, so it's a print and a read with its own effectful computations. So it's possible to create new capabilities that offer the features of others. You can have a handler that transforms the old logger into your own logger.
Okay.
What you're saying is that we finally have a use case for inheritance that is actually good. Looks pretty good. Yeah, I don't think you can do it without inheritance. Like you wouldn't be able to do this in Haskell, I think, right?
No, you wouldn't be able to compose to it capabilities without it, but no, you wouldn't be able to.
Yeah.
Just do it with records, right?
Yeah, but still you cannot pass one as another one. Like, I don't know, it depends probably in implementation detail. You cannot just guess it. But something has to have a shape and then you have to match two shapes, but I don't think you can.
Yeah.
You looked at Frank, for example, and then and maybe Unison, another thing. Do they have this like example like this for what you showed?
No, in Frank you have to say I'm taking. Okay, so in Frank you provide two different things, and in F and in all these things, where you have again the effect and the handler, and so your function says I need the effect print, I need the effect read, and then you have a handler that provides both.
Mm-hmm.
So your handler is the one that's going to compose and provide both, but your computation says, well, I need both.
I see. So like with a handler, you can kind of replace those two handlers with one handler, and then
exactly.
Yeah. So you could rewind and replace, say, like, oh, those two things is going to be my thing that now you as a user have to handle my thing, not, and I'm going to handle those things. Okay, yeah, it still works. So okay, not to the inheritance.
I don't know about Unison because I've always meant to learn it, especially when Fabio was telling me, well, this is how it works in Unison, this is algebraic effects. I really meant to start using Unison. But so many things to learn all the time. And Frank took me a while to understand because it's a messed up language. So yeah, I will eventually learn Unison. I actually plan on, if I ever have the courage, of taking all of the standard effects as defined in multiple papers and implementing them in all the languages that support algebraic effects or something like it. So Unison, Frank, F, Effect, Scala, etc., OCaml. But again, so many projects, so few hours.
I feel like I wasn't antagonistic enough. Like Jay oversold it, right? Like the thing I'm sometimes wondering is, so you start using Scala and then you become more type safe and you feel like I want more types. I want everything to be tracked in types, right? So then at some point you get to this point where you're like, IO, it doesn't tell me anything, right? That's just like open Pandora's box. So you say, I kind of want to know what it does. And I'm sometimes wondering, well, do I, right? Because it leads to these things like you were saying. So you have to annotate all the little things that it can do. So it's nice that it's compiler tracked, but do you often really wonder about these things where it's like, wow, I didn't think that this was going to make a network caller, that my read this and that thing is going to read a file, right? Like this sounds like a pure thing. Why is it doing X, Y, Z? So I don't know if there's like an obvious answer to it, but I'm really wondering if kind of the right, spelling it all out, the more you have, the more fine-grained it becomes. Or like, where would you draw the line and kind of when you do this?
It's as everything and always, it's a matter of trade-offs. I think most of the time you don't care about all the effects, which is one of the reasons why IO works, right? You just need to know this is effectful, and that's good enough. I like the granularity because all the use cases that I've had, my computations are impure in a very controlled way. So I have few capabilities. I have 4 at the maximum, right? So it's not that many. I think eventually I'm going to start writing stuff that has so many that I'm going to be, oh, I just wish I could say all the capabilities and I don't care, because it's so hard to keep track of everything. So I think it depends on the use case. In general, if it doesn't cost me much, I like to know everything.
So do you then also go like layers above this? So let's say you build some business logic and you don't just tag everything with, I don't know, reads from a file. Like you'd say stuff like maybe connects to the database, or do you say things like reads from the users table? Or, is it like, how granularly
right?
would you go and like?
So I'd probably say, in the case you're describing, I don't know the granularity I would go for, but I would definitely have something like the capability of getting users. And then somebody could provide an implementation that's database backed. Somebody could provide an implementation that's a hash table in memory. Of course, you start piling them up. And when you get to the end of the word, where everything is effectful and you run everything, then you're going to need to provide a hell of a lot of handlers, right? But you can factorize them, as I showed with TTY, right? You could say, if I provide business database, the prompt business database, so the handler, provides get user, provides get transactions, provide all of the things that I need with a single handler. But your functions are going to start piling up the capabilities. So I've never worked on such a large, that kind of project with capabilities, because I don't use capabilities at work. Nobody does. I use it for fun. And I have to admit that writing yet another web service for fun no. I'll write a language for fun. I'll write property-based testing library, not a web service. Now, maybe my notion of fun is a bit twisted if I find property-based tests fun, but this is what I enjoy. So I don't have an answer because I've not done it, but I think it's manageable, because the problem is often your functions don't have that many capabilities, but you have to provide many, many handlers because your core calls many functions with many handlers. But since you can factorize, one handler provides 17 capabilities if you want, then you don't have to declare all that much. I think the boilerplate is minimal.
I think that's where I would find it reasonable, because one thing, I think it's interesting, the whole code yellow thing, one thing we're trying to do is like, why can't lots of these things just read from the read replica? And if I could see that the thing is just tagged with like, read this, read that, I'd know, right? And the other thing is, maybe that's also just like justifying things to myself, but I think it's actually a good thing that at the end of your program, you have to provide all these things. And maybe it's even a good thing to not hide them too much behind these synonyms, because you don't want to write that, right? And maybe it's good. So you just write the big one once, and then you try to make it so that not everything does everything all the time. So I think it's fine to be honest about what things do. So I don't know.
So first, the reason why I have the synonym, the alias, the type alias, is because, for example, here in a test suite, these are all the methods that we have defined in order to be able to call a test. And so I have to write it many times because you might call it in many different ways. And it was a lot of boilerplate. I agree. Being honest about what your functions do. If anything, in a scenario where you have to identify, I have a production bug, which is related to the user table, well, a quick grep is going to tell me exactly, very precisely, all the bits of the code which can access user table, and I can discard all of the rest. This cannot happen. These are not related to the bug I'm trying to track. So it's quite useful. That's your code yellow thing, right? And I like it better. It's just, the colored function, isn't it? Where there's an affection going on. So once one of your function is effectful, then every function that calls it becomes infected, becomes colored, becomes dependent on that capability. And the article colored functions describes that as a bad thing. And I think it's not a bad thing, but generally it's seen to be a bad thing. There's this infection. It's like the GPL, right? Once you've used it, everything becomes GPL. It's dreadful. With scalability, it's the same thing. I like it. I like forcing ourselves to be honest about what our code does. But it has to be said, if you just stick everything in IO, then you have less code to write. You also have less control, but you have less code to write. So
if you go too far, you could just use all the capabilities that you know of and say type all these things together as IO, because I think that's the danger with the synonyms as well, right? Because I suppose, can you make it so that I guess, does Scala complain when you require a capability, but then you don't use it?
no,
You can't say like it's an unused variable and get a warning or something like that?
I've definitely done that, where you have a function that takes a capability that takes a function that requires capability A and B, and I've passed in a function that just requires capability A, and that works. Right?
Okay.
So that all lines up.
If you use like Taylor's final with implicits, if you use random and you not use random, it's going to tell you it's not used. But if you need applicative, if you say you need a monad, but you only use applicative, it's not going to tell you that your abstraction is too powerful. But if you say monad throw, and then random, and you don't use those, it's going to tell you. So maybe eventually when the capabilities are more mature, it's going to be able to catch it as well.
Are we agreed that this should fail to compile, or at least give me a warning, because run is required but not used?
Yeah.
And let's see if it compiles. And that's entirely for something different. That's because
random monads.
Yes. And so that compiles without a warning, right? In the test library, what I wanted to show is how searching for a failing test case is really cool. Because basically how everybody does it is we start by generating small test cases and we then bigger and bigger and bigger, but fully random. With the fact that you can replay a state, where you can generate an initial state and then modify that to explore the search space. So for example, what I have implemented is you can exhaustively test all of the small values rather than going random. So you can have, when we're running a test of searching all the test space, you can work from the assumption that if something is likely to fail, if there's a bug in my code, there's no reason for it to be in the big values more than in the small values. So let's first start by exhaustively checking the first one to have in the small values. When this, you can have access to the state where you start with a state where everything is 0, and then you find the smallest value incremented by 1. Smallest value incremented by 1, and that's going to increase the size of the test cases a little. You can do probabilistically. You can say, right, I'm going to generate a random value, and then I'm going to flip the distribution, the probability distribution, to generate the most different possible I have. So you can implement different ways of exploring the test space. And then, of course, shrinking, you can have different strategies for shrinking, and then you can plug different search plan with different shrinking strategies in order to explore your test space. And I was even started to write a CLI where you say, this is my test. Test it exhaustively to begin with. Didn't find anything. Okay, try random. Okay, shrink it that way. Use this other shrinking algorithm to see whether I get something shrunk further. I don't know. It sounds like a lot of fun. It's also a lot of work, but it's a lot of fun. So I'm having a lot of fun with that. This was supposed to be about, the fun of programming. My library here, I'm having so much fun doing things.
But what are your plans for the library? So which spaces are you exploring next with the library? Like this, what you mentioned, or there is some other things that you're exploring as well?
There's a few things that need to be implemented that I haven't. As Mark pointed out, I should do this distribution thing to know the repartition of the kind of test cases. So I want to know whether I'm mostly generating empty strings, for example. And I don't yet have a reasonable implementation of random functions, which I want to do. So there's a bunch of little things, but really I use my testing library for my own project. So it's already good enough to be used. It's just I haven't published it yet.
I was just curious about the thing you said about the shrinking and that kind of stuff. All these things that you just mentioned now, they're independent though of like the capability stuff, right? Or are they only enabled because you use capabilities?
Capabilities made them easier to write. Okay. And also they've forced me to write it that way because capabilities with monads, you have a monad to work with. So you can, for example, write a shrinker for a given type. But with capabilities, you don't have that. You just have the handler and the output value at the end. So that forced me to realize it's okay for my handler to be stateful. if your handler is stateful, then you can record all of the randomly generated numbers. Then you can play with that and replay it. And so capabilities made it much easier for me to do that in a way that I had never done before, because before that I had monads. So no mutability. Here you need mutability because you need to record all of the randomly generated numbers, right? Now that I know how to do it, I could probably do it with monad, some sort of state monad, but capabilities made it so much easier for me to do, and it's just fun. I never had to do flat traverse at any point, and that honestly, any day I don't have to use flat traverse is a great day.
Do you have any other parting thoughts on, like, for people about property-based testing, about your library, about Scala, capture checking capabilities? Any final thoughts?
As far as the library is concerned, if you're interested in it, let me know, because at the moment I'm the only user, so I have very little incentive to actually publish it. So please let me know. Honestly, capabilities, capture checking, all that, I think it's going to be great. I think it's going to be well fun. I think it's going to make Scala cool again, because we're going to get most of the benefits we get from monads, not all of them, but most of them. And the cognitive cost is going to be so much smaller, because you can write in an imperative style, in a direct style. So most of the ways we've learned to program, because I mean, some of it, I think, Jade, you started learning monads really early in your career, but most people don't encounter them that quickly and that early. And it's right, you're in a team, and somebody's just been recruited, they're fresh out of university, they sit down and they've learned all these programming languages, they've learned to do all these complicated things. Then you tell them, right, you're almost ready, read these 5 books. You have 1 month, and then you can start writing useful code. And then you don't understand why they quit. So I think the monad tax is so high. And I think capabilities are going to, as Mark said, it might be a gateway drug. You get into capabilities, you do all these things, I want more, I want the continuation, I'm going to do monads now. But at least it's going to make it possible for non-experts, non-senior developers to start doing this kind of stuff in Scala. Unfortunately, one of the possible future users of this is Martin is working on how capabilities can allow us to use LLMs better. I hope that's not the future. I hope the future is more people are going to write code in Scala rather than agents, because that's not fun. And capabilities are well fun.
Cool. Thank you.